Picture a mechanic in 1965, standing over the open hood of a Chevrolet with a 327 cubic inch engine rumbling beneath his hands. No laptop, no diagnostic port, no error codes blinking on a screen, just his ears, his hands, and 30 years of hard-earned experience telling him exactly what was wrong. This video will show you why this method disappeared and how to bring it back step by step. By 1965, V8 engines made up about 75% of all engines produced in the United States, according to Automotive News. These were not simple machines. Ford was pushing its 289 and 390 cubic inch engines. Chevrolet had the 327 and was about to drop the legendary 396 big block in 1966. Chrysler had its Hemi, which became a force in drag racing by 1967. These engines were powerful, complex, and built to perform. Keeping them running right required more than a wrench. It required a trained set of ears. The goal for any serious tuner was getting a V8 to produce roughly 1 horsepower per cubic inch. That was the benchmark that separated a well-tuned engine from a mediocre one. Hitting that number meant everything had to be dialed in perfectly, and the mechanic had to hear his way there. The carburetor was the first battleground. A V8 in the 1960s often ran a 4-barrel carburetor, and getting the fuel and air mixture balanced across all 8 cylinders was painstaking work. A rich mixture made the engine sound rough and heavy, almost like it was drowning. A lean mixture created a high, hollow sound at idle, sometimes with a faint popping. An experienced mechanic knew both sounds by heart. He would turn the mixture screws slowly, quarter turn by quarter turn, listening for the idle to smooth out and rise slightly as the mixture hit the right spot. When all 8 cylinders were pulling evenly, the idle changed its character entirely. It stopped sounding like separate events and started sounding like one steady, clean pulse. That sound told him he was done. Ignition timing was next, and this is where the ear really earned its keep. Setting the timing too far advanced caused a metallic rattling knock, especially under acceleration. Mechanics called it pinging. It sounded like someone tapping a hammer lightly against the block. Too far retarded and the engine lost power, ran hot, and produced a dull, flat exhaust note that any experienced tuner recognized instantly. The mechanic would use a timing light to get close, shining it at the timing marks on the harmonic balancer while the engine ran. But the final adjustment often came from listening. He would advance the timing until the knock just appeared, then back it off until it disappeared, finding the exact edge where the engine made the most power without tearing itself apart. The tools of the era supported the senses, but never replaced them. A dwell meter measured the angle of the distributor points, telling the mechanic how long the ignition circuit stayed closed per cycle. A vacuum gauge showed intake manifold vacuum, and a dropping or fluctuating needle told a story. A steady low reading suggested retarded timing. A needle that fluctuated rhythmically pointed toward a weak valve spring or a burned valve. A vacuum gauge bouncing erratically at idle could mean a cracked intake manifold gasket. The gauge gave the clue, but the mechanic's ear confirmed it. He would listen for a subtle ticking or a small, irregular misfire buried inside the idle and match that sound to what the needle was doing. Feeler gauges handled valve clearances. Setting the valve lash on a V8 with solid lifters meant working through the engine cold, slipping a thin metal blade between the rocker arm and the valve stem, and adjusting until the blade slid through with just the right amount of drag. Get it wrong and the engine would tell you. Too tight and the valve stayed slightly open, creating a faint hiss and a rough, uneven idle. Too loose and you heard a distinct ticking from the top of the engine, a rhythmic clatter that varied with engine speed. Mechanics learned to distinguish that tick from normal valve train noise, and they could often identify which cylinder was the problem just by the pitch and location of the sound. Warn lifters had their own voice. A collapsed hydraulic lifter produced a clacking sound at the top of the engine, heavier and more irregular than a simple lash issue. A mechanic who had heard that sound 100 times knew it immediately. He could place a long screwdriver against the valve cover and press his ear to the handle, turning the engine block itself into a stethoscope, isolating which side of the engine and which cylinder the noise was coming from. When Pontiac launched the GTO in 1964 and sold over 32,000 units in its first year alone, according to official Pontiac records, it created enormous demand for performance tuning. Mechanics who could get results built reputations fast. A tuner known for making a muscle car run right could charge significantly more than the shop down the street, and customers drove miles to find him. That reputation was built entirely on the quality of what he heard and what he did about it. The 1960s racing world reinforced these skills. NASCAR showcased V8 performance at the highest level, and the Sports Car Club of America brought performance tuning to amateur racers across the country. Mechanics who worked on race cars developed hearing that bordered on extraordinary. They could walk past an idling engine at a track and call out a problem before the driver even noticed it. By 2024, engine management systems handle all of this automatically. Oxygen sensors, NOx sensors, and fuel trim tables make real-time adjustments thousands of times per second. A scan tool reads a fault code and points directly at the problem. Nobody needs to listen anymore. But a growing community of collectors and vintage car restorers still insists on doing it the old way. Not because modern tools are inferior, but because the old way connects the mechanic to the machine in a way that a code reader never can. There is something that scan tools cannot teach, which is what a healthy engine actually sounds like when everything is exactly right. That knowledge lives in the hands and ears of people who learned it the hard way. And for anyone working on a classic muscle car from the 1960s, it is still worth learning.